Okay.
Good sleep.
Right, okay. So the last lesson now. So let's see.
In the past, we used to finish at 4:30, and now we have to take a full 3 hours.
In the past, our life was easier. Not anymore. Okay. Well, I tell you what, Mustafa, the good news is it's only really one example. And there's no new formulas, it's just different. What was that, Ching Don?
Sorry.
You sounded worried over there. Right, I'll give you an example now. Okay, so what you have is, you have. Oh, no. Why is it doing this thing again?
So we'll stop.
No, I don't want to. Hang on. Just wait. Maybe I can fix it. Fudge. Fudge.
It's not recording, right?
It is actually. I'm just saying fudge. Oh, fudge.
You just say tuck.
What?
Just say tuck.
All right. I'll have to deal with it. Right. So you have ceiling here, like the ceiling, and you have a particle, and it hangs down here, and its mass is half or quarter kg. The length of this string, the natural length, is 2, and the K is 49. And these are all, here is meters and here is newtons per meter. All right. It's released from rest from a point 2 meters below the ceiling. 2 meters below the ceiling. Show that find out of the time taken. Find out from each point Q, which is okay. All right. So, in this one here, I'll make it a little bit different to what's in the book. So in this one here, you have this ball and it's hanging down. Now the
equilibrium or smoothie?
Yeah, well that's what we'll do. First we'll find out where the equilibrium position is. So what forces act on this ball?
mg.
Yeah, mg. So that would be a quarter g.
Yeah, and the reaction force R.
And well, it's a type of upward force. What type of force?
Reaction, right?
I won't call it reaction because that's usually when you have the ground.
Yeah, but the force you give us in the statics was what's the reaction force?
Yeah, well in statics it would be a reaction force, whereas here it's because of the spring.
Just the R.
Yeah, what's the formula for spring force?
R equal mg.
It'd be minus k
Okay, minus kx.
x, which would be the length of the string minus 2.
Yeah, x minus 2.
So yeah, x minus 2 here. X minus 2. And let me just call the total here x. Okay? Now, actually we know what the k is. What's the k?
49.
49. So let's find the x. So let me go down a little bit. So I have minus 49 x minus 2. That should equal a quarter g. So can you...
How to get the quarter g?
that is equal to mg. It's equal to the weight.
Oh, yeah.
Okay. Now, that's going to be minus 49x plus 98
Yeah, 98.
equals g over 4. So I will get 98 minus g over 4 equals 49x. So Albert, please, can you tell me what this is?
Just a minute. No, you are using a different one. So the 98 will take that side will be g over 4.
No. I'm taking this to the left and the x to the right. Why? Because I want the x to be positive and it's negative on the left. Albert, what's this here?
95.5.
Now please divide that by 49.
It's 1.95.
1.95.
95.
Are you
Not saying, yeah.
1.95.
I like it.
No, I don't. It should be bigger than 2. Did I make a sign mistake? Minus.
No, that's right.
No, that's right. Yeah, that's right, yeah. Because imagine this. Imagine the K was really, 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 really big. Imagine you have your spring and the K was so big that when you put the ball at the end, it doesn't move. Can you imagine that?
Yeah.
So then that means it should be near the natural length, bigger than the natural length, not smaller.
What happens if you delete the minus?
Did I make a sign mistake?
No, it's correct.
Ah, thank you, Ted. There's no minus here.
Why? The K must be minus.
I said the up force equals the down force, so you don't put the minus in. Yes?
So the minus 1.9?
Wait, hang on, let me clean this. Oh, well, you know what? I'll just travel back in time.
What's it called? Movie?
Yeah,
What was?
Back to the future.
Yeah.
Well, it happened a few while ago.
49x minus 98 equals g over 4. So I get 49x equals 98 plus g over 4. So x equals,
Minus 1.9.
it'll be, what will it be, Albert? It should be. I'm really hoping it should be more than 2.
G code
9.81 or 9.8.
Okay.
Yeah, it's more than 2.
Good.
It's 2.05.
Good.
4.
Yeah, at least.
That would make sense. So the natural length is 2, and then you stick the ball at the end, and it goes down a little bit.
No. No, I mean quiet.
Yeah, quiet, yeah.
You? What?
No, you'll have to watch the video tonight. I need to continue because the time is short.
Well, I have one.
Oh, all right.
Not right now. I just have a question.
Okay. Yes.
Color G. One color G. Yes, it's here.
MG,
Yes.
G, and
G,
M.
how to get the 1 over 4?
Because it's M is 1 over 4.
Oh, M is 1 over 4.
Yeah.
Not 1 over 2.
No, 1 over 4.
Sorry.
Okay. Right. Next. Can I continue with this?
Yeah.
Now, different question. So we need to remember this answer, okay? We need this. So don't forget this. Now, next situation. It's the same ball and the same string. Not in equilibrium now. Instead, I pull the ball down until the distance here is 3 meters. So, Mustafa, where's the equilibrium position?
In the middle.
No, we calculated a moment ago.
X is 2..
2.05. So if I pull it past 2.05 and let go, what should happen? What should happen? Leslie, if I pull this down
That's 3 meters.
and let go, what happens? Yeah, it goes like this. Yeah.
It's a turn.
Yes, SHM. SHM.
It's a turn.
Simple harmonic motion. It goes like this.
Yeah.
So we want to calculate this simple harmonic motion. We want to calculate it. So, first, yes.
One is down.
Yes.
And when you make it up,
Yeah.
the something is minus what?
Yeah, well, we're going to do it now.
Yeah.
You can see now. So what happens is, look please, it should be here, it's at rest, and x is 2.05, okay?
What do you want from now?
I want to calculate like the a and the omega and all that stuff. So look, here it is at rest. If I pull it past the rest place, it will go
To X.
up, down, up, down, up, down like this.
Before A.
It'll be SHM motion. And I want to calculate things for it. So let's have a look. What you do is you call this distance here. You call this one. Let's call it S. Yes.
The 2.05 is that, so shouldn't that be the extended part?
Hmm?
Shouldn't the 2.05 be the extended part from the
2.05 is from here to here, and then the tree. So that means like here to here would be, what's it, 0.95 or something. Yes. Anyways, I need to continue. So let's calculate. What's the total downforce? Well, that's still a quarter G, mg. What's the total up force? Well, that's going to be K. What's K?
It's 94.
Is 49.
49.
And then you do how much bigger it is than the natural length. What's the natural length?
1.
Nature 2.
2.
2, yeah, sorry.
Okay.
X minus 2.
Yeah, so here, what's the total length? The total length is 2.05 plus S. That's the total. 2.05 plus S. And then I do minus, what? Minus 2. Okay? So that is the, well, are we clear with this?
You mean 1 over 4G equal that one?
Yes. Well, no. We want to know what the total is. So we do this one minus this one, okay? So the total F will be 49, 2.05 plus S minus 2 minus a quarter G. So the total F equals 49, or what, 2.05 minus 2, what's that? 0.05. Multiply 49.
2.45.
Now, G over 4 will also equal that number you just said.
Yeah.
So what ends up happening is all the numbers cancel and you are just left with 49S. That's what you're left with.
Okay.
Because when you multiply this number by this number, and then this number by this number, and then you take away this number, they all cancel. So that, and that cancel, you're just left with 49S.
Yeah.
Now, Ted, please tell me what Hooke's law is.
What?
Hooke's law at the very start of the class.
Minus
Kx minus Kx. So, do you notice anything similar with these? In this formula, what does S represent?
X.
Distance.
Distance. And in Hooke's law, you see you have Kx.
Yeah.
You see, these are the same formula. I just use a different letter, but they're the same, right?
Mm-hmm.
So this will move with simple harmonic motion, and the K will be 49. Okay?
Yeah.
So it'll be simple harmonic motion, and the K is 49. So I'll go to the next page. Now, what will the A be? Who can tell me what the A will be?
A equal.
Now remember, you're talking about S. So S goes like this. What's A going to be in this example?
A would be
A max or normal?
A max.
A max.
0.95. Because the biggest this S will be
yeah.
is 0.95, and then it shoots back up. So the biggest the S can be is 0.95. So you have A equals 0.95 and K equals 49. Okay? Now, don't forget you have a formula for small a. That equals minus omega squared a, doesn't it? Yes? Right? Is that right?
I think so.
I think so, yeah?
I think it's not minus.
Yeah.
Well, I won't care about the okay.
No, it's not correct. A equals
There.
minus.
What?
Yeah.
A max.
Yes.
Yeah, sorry. What's A max?
Mx equals
W
w square a.
Okay. Right?
Yeah.
Now, if I multiply both sides by m, this becomes F max, right? Which equals m omega squared times a. Now, please listen. When I pull this down, when is the force the biggest? At the beginning.
Force?
Yeah, if I pull it down, when is the force the biggest? At the start. Because when I let go, what happens? It moves up.
Yeah.
Does it go,
Come to zero.
what happens is the spring gets smaller. So does the force get bigger or smaller?
Bigger.
You mean the biggest force means
Okay, no, all right. Listen. If I pull this down,
Yeah.
I'm only talking about the spring. At the beginning, it's like this. I let go, the spring gets smaller. What happens to the force?
Bigger.
No, it gets smaller also, right? Now, does the gravity force change? No. So what happens to the total force when I let go? Bigger or smaller?
Bigger.
Bigger.
Smaller. Smaller.
Total force.
Total force will get smaller.
Oh yes.
Okay? So when will the force be at a maximum? At the beginning. So wait. So the force will be a maximum at the beginning. So let's calculate that. What's the total up force? That will be K times 1. Why did I use 1? Because how big is it at the start? 3 meters. Yes? And what's the natural length? 2. So the force will be 49. 3 minus 2. Now, we have to take away the gravity, which will be G over 4. So, Albert, please calculate this. 49 minus G over 4.
46.55.
55
Yeah.
newtons. That's the maximum force. Agreed?
Yeah.
But we also have this formula for maximum force. Yes? So I can say that equals a quarter, well, it can equal a quarter times 0.95 times omega squared. So I can say omega squared will equal 46.55 multiplied by 4 divided by 0.95, and then I do square root and cancel that square there. So what do I get now, Albert? .95. 46.55 times 4 over 0.95 square root.
0.95.
0.95. Just give me the total, please, the final answer.
14.
Exactly?
Yes.
Beautiful. 14. So now I can calculate the T. What's this, please, Albert? Pi over 7? 0.449 seconds. So, in this example, watch, look. Look here. I take the ball, I pull it down 3 meters, I let go. How long until it's back in my hand? 0.449 seconds. Okay. I can imagine this as a question in the exam. You know, the question in the exam would say the natural length is 2, the mass is a quarter kg, and you pull the string down 3 meters. How long until it's back in your hand? You could get that in the exam. So I'll just write the question down so you can have it in your notebook. So, string with k of 49 and natural length of 2 is pulled down to a length of 3 meters. How long until it is back in your hand? What you doing? Why are you packing your stuff away? We still got 20 minutes left.
How long until?
How long until it is back in your hand? Very difficult question, I know, but it doesn't get more difficult than this in the exam. So I guess that's the good news. Yes.
How long what?
How long until it is back in your hand? Yes, Albert.
The ball is stretched. Because it's stretched, because you stretch it. But if you let it go, you will go back original, you will go back to the natural length. You wouldn't go back
No.
to the same height as your hand. So that means obviously
No,
you have to
no,
go to the
No,
natural length.
no.
Then how does it work?
No, like picture it. If you have a spring and I pull it down, it will keep going like this. But not in the real world. In the real world, it'll go like this because of the air friction. But if there was no air friction, it will just go.
So we go back to the original position.
Which, in your hand, yes.
But not to the natural length.
It will never go back to the natural length. Now, if there was air friction, it will go back to its natural length. But we have not discussed that yet. That is
But
not for us yet.
there is no air friction, there is no gravity.
Oh, no. You can have gravity if there's
Is
a.
it the new unit or the same unit?
No. Like picture this room. If I take all the air out of this room, there's still gravity.
So we just vacuum out.
Yeah, vacuum out the air. Yeah, that's all. Yeah.
What's gravity?
Huh?
Gravity.
You're not asking what gravity is, are you? Because I think that will actually kill me. Are you really asking what gravity is?
No, I'm kidding.
Thank goodness. I really hope so. Okay.